Hello and welcome. In this video we want to do a question about instantaneous rate of change and average rate of change. A roast chicken is taken from oven when its temperature is 110 degrees and is placed in a room where its temperature is 25 degrees centigrade. Estimate the rate of change of temperature of the roast chicken 10 minutes after. So this graph here shows the temperature of the roast chicken, and as you can see, the roast chicken temperature at the beginning is 110 degrees. Gradually the temperature decreases to the temperature of the room. Now we want to estimate the rate of change of the temperature of the roast chicken 10 minutes after. 10 is here, so 10 minutes after on the curve is here. So we want to find the instantaneous rate of change, or briefly rate of change. Attention, rate of change or instantaneous rate of change are the same here because we want to find the rate of change at 10 at this particular point. This is different than the average rate of change, which is over an interval. For finding instantaneous rate of change or rate of change, we have to draw the tangent line to this curve at 10. So we have to draw the tangent line. The tangent line is something like this. Attention, this is an estimate, so maybe you draw a little different tangent line, but it should be almost the same. This is the tangent line at 10. Now for estimating rate of change at 10, we have to estimate the slope of this tangent line. Why we do so? Remember, rate of change, a slope of the tangent line, a slope of the curve, all of these are same thing, but these are different interpretations for derivative. So derivative is rate of change, instantaneous rate of change, a slope of the curve, a slope of the tangent line, and that's the reason all of these are the same. For finding a slope of a line, we use the formula rise over run. So a slope of the tangent line is equal to rise over run. Rise is y2 minus y1 over x2 minus x1. For example, I consider this point and this point as the 2 points that I want to use for estimating the slope of the tangent line. Here it seems to be something like 90 degrees, and for this point here is 25 clearly. So y2 minus y1 would be 90 minus 25, or 25 minus 90. I consider this point here my first point and this as the second point. So y2 would be 25 minus y1 90 over x2 minus x1. What is the x coordinate of this point? It is almost 28. What is the x coordinate of this point? This point, the x coordinate is 0, so minus 0. By calculating this fraction, we can estimate the instantaneous rate of change of the temperature of the roast chicken 10 minutes after. 25 minus 90 is negative 65 over 28. Negative 65 over 28 is approximately negative 2.3. So instantaneous rate of change or rate of change of the temperature is negative 2.3. In the next part of this question, we are asked to estimate the average rate of change of temperature from T equals 0 to T equals 50 minutes. For average rate of change, we need to have an interval, and as you can see, we have an interval. We want to find averagely what is the rate of change of temperature from 0 to 50. At T equals 0, the temperature is 110 degrees. And at T equals 50, the temperature is a bit above 25. We can say 30 degrees, 28 degrees. This is an estimate, attention. We cannot find exact answer from a graph. I consider here to be 28. So, average rate of change shows the slope of the line, of the secant line that connects these 2 points to each other. So it shows the slope of this line, this secant line. The slope of the secant line, or average rate of temperature from 0 to 15 minutes, is slope equals, again, rise over run, y2 minus y1 over x2 minus x1. y2, for if we consider this point as the second point, the y2 is 28 minus y1, the y value or the temperature value for the first point is 110, over x2 minus x1. Attention, we don't have y values and x values in this question. We have t as the time for the x, and we have the temperature in degrees centigrade for the y values, but we use the same letters y and x. x2 minus x1. For the second point, the x coordinate is 50, and for the first point here, the x coordinate is 0. This equals negative 82 over 50. If you divide negative 82 by 50, this equals to negative 1.64. And this shows the average rate of change of the temperature from 0 to 15 minutes. Let me draw the secant line again here. This is the secant line. I hope you like this video, and see you in the next videos.